Nowadays, vehicles are everywhere. It is estimated that over 1 billion passenger cars travel the streets and the roads of the world today. At the turn of the 20th century, the impact of the automotive industry has been groundbreaking. In a few years, it completely changed the landscape of cities as well as the habits of the mankind. While innovation has never stopped, improving characteristics such as reliability, safety, and comfort, most people believe the industry is close to a new breakthrough. In recent years, the focus started shifting more and more from mechanics to electronics, computers, and software. Indeed, when we imagine the vehicle of tomorrow, we envision features such as autonomous driving, advanced infotainment systems for novel interactions between the humans and the machines, as well as ubiquitous connectivity in the smart cities context. Although technology is increasingly becoming a distinguishing factor between different makes and models, at the same time it is introducing a high strain on the industry in terms of costs, complexity, and weight. A possible solution may come from the concept of resource sharing, both within a vehicle and between multiple vehicles and infrastructure, to achieve a more efficient use of computing resources and, at the end of the day, cost savings. A similar concept recently emerging in the ICT world is that of liquid or ubiquitous computing. Essentially, in these paradigms, applications are not bounded to one specific device, but seamlessly and transparently migrate from one to another, depending on the available resources and the specific constraints. In this context, LICO is an open source project we started at Politecnico di Torino to implement the idea of opportunistic, dynamic, and transparent resource federation. Built on top of industry standard cloud computing components, LICO leverages the same highly successful peering model of the Internet without any central point of control. While many challenges still need to be addressed in safety-critical environments, let's see LICO applied to an everyday scenario, struggling many students. Have you ever complained that your laptop was not powerful enough while working on that computer graphics project, or recompiling for the 10th time the entire Linux kernel during your thesis? Still, look at how many powerful computers are scattered around our labs, underused, especially in this pandemic period. Wouldn't it be great to transform those resources in opportunistic data centers to offload heavy tasks? Let's start. First, let's open the LICO dashboard. We can see a list of devices and clusters which are available to peer with. We choose to connect to our laboratory, hence leveraging the resources it makes available to us. Then, we start a LICO-enabled instance of Blender. Essentially, it consists in a wrapper required to set up the environment and spawn vanilla Blender in the best available location. In this case, it will be automatically executed in the remote cluster, as we want to take advantage of GPU acceleration for faster rendering, which is not available on this laptop. Still, no workflow disruption is perceived by the final user, who interacts with the application as if it were executed locally.